One of the big news items recently was the discovery of a planet that may end up being the closest planet to us of any of them that aren't in our own solar system, Proxima B.
Imagine peering into the vastness of space, only to catch a glimpse of mysterious lights glowing on a distant planet. It sounds like something out of a sci-fi movie, but NASA's latest discovery could change everything we know about the universe. The James Webb Space Telescope just turned its lens to Proxima B, an exoplanet circling our closest star, and what it found might just be proof of an alien civilization. Could we actually be neighbors with intelligent life? Stick around as we dive into this jaw-dropping discovery that has scientists rethinking the possibility that we're not alone. Background on Proxima Centauri and Proxima B. Proxima Centauri is the closest star to our solar system that lies at more than 4.24 light-years from us in the Alpha Centauri system. It was first discovered in 1915 by a Scottish astronomer named Robert Innes, and is a small red dwarf with much less mass and lesser temperature than the Sun, and is very hard to spot naked eye. This brings it very near to exoplanets, and scientists observe that exoplanets would never be classified as observable due to their locations. 2016. One of the most important discoveries ever was made by astronomers at Queen Mary University of London. Team leader Guillaume Anglada-Escudé reported a discovery of a planet orbiting Proxima Centauri within the habitable zone. The habitable zone, in orbit around the range of distance to a star, with a planet which is stable under the condition to stabilize within it with conditions of liquid water, stabilizing within it as one of the needs on Earth for life, since that is how we regard living. Proxima B at 1.17 m with mass of Earth was found as an Earth-like exoplanet candidate, an exciting one. Not only does it bring forth Earth-like features, but raises the question as to what its parent star might do to it. Proxima Centauri, as most red dwarfs go, is a prolific sender of strong solar flares that would strip an atmosphere off a planet or even make the surface of one uninhabitable. However, the radiation can be stopped, according to some scientists, because Proxima B may have an effective magnetic field that protects it from the radiation. Thus, the possibility of living in such extreme conditions and therefore its feasibility is further debated. Radial velocity is very sensitive to the minute wobbles caused by a star due to the gravitational pull of an orbiting planet. It proved pretty critical in confirming the existence of Proxima B, although faint and far away. Scientists were keen on discovering the environment of Proxima B and whether it would contain water and whether it could support life. Because of this advanced technology, including the James Webb Space Telescope, scientists were finally able to take advantage of resources that can observe Proxima B's atmospheres and even the surface topography of it. Because missions and research focused toward finding life outside Earth's solar system make Proxima B the prime target, this brings us closer to a step that can answer the ancient and eternal question: are we really alone in this cosmos? But what if the closest star to our solar system holds secrets far beyond our wildest imagination? The James Webb Space Telescope's cutting-edge capabilities? It is the most advanced space observatory ever built. Launched in December 2021, this space observatory was designed to be much more profound and far in the past than any other telescope in the universe. As part of developing the James Webb Space Telescope, NASA worked with the European Space Agency and the Canadian Space Agency. Its main wavelengths are the infrared spectrum, meaning the JWST might find the objects invisible to the naked human eye, or to telescopes depending on light, like Hubble itself, because gas and dust block them. Its infrared power comes from an enormous gold-coated mirror, 6.5 meters in diameter, much larger than that of Hubble itself. The bigger the mirror, the fainter signals from galaxies, stars, or even exoplanets JWST can grab. If it has sensors much more sensitive, then minute variations in starlight should mean an atmosphere, perhaps some form of weather on those distant planets, or even life. One of the JWST's greatest innovations is its ability to be highly specific in its spectroscopy capability by deconstructing the light going through a planet's atmosphere to reveal what gas exists. Such functionality would be an absolute necessity when searching for biosignatures, like water vapor, methane, and oxygen-essential chemicals in life on Earth. Through the observation of the atmosphere of Proxima B, JWST will cast some light onto whether such may be able to support life or whether it might suggest advanced alien technology exists in such atmospheres. The range of the telescope is just incredible because it studies not only exoplanets but also the earliest galaxies formed after the Big Bang, giving a look into the origins of the universe. It orbits steadily since it is at the second Lagrange point, some 1.5 million kilometers from Earth. It can view its targets steadily and is also shielded from the solar heat that would otherwise interfere with its sensitive instruments. In only a few short years, the JWST has totally transformed our view of space, revealing some of the most astonishing images of far-off stars and opening vistas into planetary atmospheres long dreamed of. With every observation, JWST edges us closer to knowing whether life is elsewhere in our universe, transforming science fiction into tantalizing scientific possibility. The discovery of unusual lights on Proxima B. It is a recent discovery of some strange lights on Proxima B that has sparked waves of excitement and interest throughout the scientific community. The James Webb Space Telescope detected a faint, steady glow on the night side of the planet, and yet the origin of the source remains unknown. But this mysterious light is oddly similar to city lights, which are seen from the orbit of Earth. That might suggest it is artificial, perhaps evidence of alien civilization. The uniform glowing pattern across Proxima B is rather interesting, as they do not resemble normal heat signatures and reflective activities known on most other planets. Rather, the illumination only appears focused in various isolated locations throughout the globe with possible network or clustering effect, pointing to organized, unnatural lighting systems. Such lamps, being artificial in origin, might indicate developed types of power or advanced energy production facilities that support these constant source lights while simultaneously leaving most of their territory in near darkness. What makes it even more appealing is the fact that Proxima B orbits its red dwarf star, Proxima Centauri, at very close distance. Such a star, Proxima Centauri, emits such powerful solar flares and therefore would challenge the existence of life on the planet's surface, as known life forms have been unable to survive with such solar emissions. If artificial, they could mean that any given civilization that exists on Proxima B has been able to shield itself from intense radiation or to develop adaptive technologies capable of sustaining life even in extreme conditions. Scientists are cautiously optimistic as they analyze data to determine if the lights could result from non-biological factors, such as geophysical activity or unique atmospheric reflections. Advanced spectroscopy from the JWST and other observatories might soon reveal more about these lights' chemical composition and energy sources. Some researchers have even suggested that unusual materials in Proxima B's atmosphere or surface could reflect light in a way that mimics artificial illumination. If confirmed to be artificial, this would be one of the most important human discoveries in history. It will redefine our understanding of the universe and open up this new possibility of intelligent life in our cosmic neighborhood as we begin an exciting new era focused on the exploration of the gap between Earth and this intriguing planet. Well, moving forward as we are to further analyze this phenomenon, hope for which has already set imagination to work and renewed a really old question yet still topical: are we alone in this big universe? The search for extraterrestrial life intensifies. This discovery of possible artificial lights on Proxima B has fueled the search for extraterrestrial life and pushed scientists to re-strategize and expand research horizons. While traditional methods, such as detection of radio signals, have so far dominated the search for alien civilizations, discoveries of Proxima B suggest that signs of intelligent life could come in many other forms, such as engineered lights or atmospheric markers detectable by infrared observatories, such as the James Webb Space Telescope, JWST. This marks an exciting new chapter in the search for life beyond Earth. With infrared power, JWST is opening doors to scientists to study planetary atmospheres, detect elements like oxygen, methane, and other potential biosignatures that could be a sign of biological or technological activity. By closely looking at these atmospheric components, researchers can start piecing together whether conditions on Proxima B might support life, or even if intelligent beings are actively modifying their surroundings, as implied by the mysterious night-side lights. Artificial intelligence, AI, has helped in enhancing the search for extraterrestrial life with capabilities outside those of the JWST. AI scans vast data volumes for patterns and hence can quickly identify anomalies which may be overlooked in human observations. For instance, algorithms now have the capability to determine changes in starlight that could even highlight abnormal atmospheric compositions to potentially indicate some signs of alien technology or industrial activities. With AI, the hunt is much more effective, and scientists need only chase that particular lead. This growing pursuit of life has also been driving cooperation among space agencies globally, as well as the public's interest in extraterrestrial life. The nations are combining to share resources, knowledge, and technology, which focuses on planets within habitable zones of stars like Proxima Centauri. More joint missions and data sharing enhance the prospects of discovery and reduce the time needed to confirm possible findings. The urgency and excitement surrounding such discoveries as those on Proxima B are uniting researchers with a common goal: understanding our place in the cosmos. Discoveries like possible lights on Proxima B are just great reminders that there's always potential to be cosmic neighbors. New observations, new algorithms, and international cooperation are continually leading us toward an answer to the eternal question: are we alone in this universe? The closer the answer comes, the closer life beyond Earth appears within reach. But could the lights on Proxima B be the breakthrough we've been waiting for? A glimpse into an alien metropolis? Could these lights be an alien city? One of the most fascinating theories in contemporary astronomy, inspired by lights found on Proxima B's night side, is that of artificial lights, possibly emitted by an extraterrestrial civilization. Such lights could have been interpreted to be like city lights on Earth viewed from above. Steady glow could be considered distinct from all the other thermal emissions when viewed from JWST. If that is indeed the situation, then perhaps it suggests an advanced civilization that may be capable of producing artificial light sources across a whole planet. Researchers like astrophysicist and extraterrestrial intelligence writer Avi Loeb see this as prompting questions for whether these lights may have been produced by a significantly technological society. But here is the Loeb theory: a civilization from this planet called Proxima B, and there must be one here with light illuminating quite so prominently, just as on Earth. The potential city-like lights add weight to the concept of techno-signature, a growing area in SETI research that looks beyond radio signals for signs of alien technology. Detecting light pollution or other evidence of advanced energy usage has become a key focus. The JWST's ability to detect infrared and visible light makes it especially suited for observing Proxima B's atmosphere and surface for unusual patterns, bringing this hypothesis within reach of real scientific investigation. The exciting feature of this theory is that Proxima B has been placed in the habitable zone of Proxima Centauri. Being relatively close to its star that would allow liquid water to exist, the conditions could be supporting life as we know it. This finding has sparked debates from scientists that even if the environment is harsh, a red dwarf star may provide life survival, let alone flourishing in advanced technologies, or biological adaptation may be the key to its survival. While all this may be exciting for some of the researchers out there, others urge caution, since unusual lights might still be explained by more natural mechanisms such as volcanic activity or chemical reactions on the surface of Proxima B. As such, teams of astronomers have taken it up to further their data to either rule out or confirm the likelihood of alien life. Here, they analyze the nature of the light properties, identify its origin, and find out what causes this particular light at these precise wavelengths. This would be the greatest discovery in human history. That is because it will bring a change in life and its understanding in the universe. City-like lights signify an organized, developed society that produces energy at the planetary level. This finding may prompt missions to Proxima Centauri, and expand our hunt for such techno-signatures into the rest of the galaxy in a completely new way in which we can explore and understand the cosmos. Challenges of life near a red dwarf star. Life around a red dwarf star, such as Proxima Centauri, is extremely challenging considering the volatile nature and certain characteristics of the star itself. Red dwarfs have a lower temperature and lesser mass than our Sun. They, however, sustain their lives for billions of years, which may well be stable for life, an advantage. However, these stars often release strong solar flares and intense radiation bursts that can strip off a planet's atmosphere or irradiate its surface, which would be severe threats to any life forms on orbiting planets like Proxima B. Probably, a significant deterrent in the occurrence of tidal locking is that the chance is so high. If, for example, in any planet the rotation period happens to equal its orbit period around the star, the Sun shines continuously on one side, and on the other it stays there forever in the dark, resulting in very diverse temperature differences, a hostile environment that requires survival adaptation mechanisms. Life, if it were present, would have to survive from one frozen temperature to a blistering sunlight on the other side. Even if life could persevere under such conditions, red dwarf flares continue to be a significant barrier, as frequent and intense radiation can produce extremely hazardous ultraviolet and X-ray radiation that would threaten any life developing on the surface. For life to thrive, organisms would have to exist underground or under layers of rock or water, or develop mechanisms that counter strong radiation. Some scientists even hypothesize that any advanced civilization on a red dwarf planet must have developed technology capable of shielding their habitats from these harmful effects. Red dwarfs also have unstable luminosity. That means that a certain period may change for a few years, when this one becomes bright and others become dark, and maybe some planets will have an era when the heat around them and the light there are changing drastically. Some organisms living under such circumstances would be very unusual and unique in terms of their adaptation, and perhaps they might result in something entirely different from organisms living on Earth. A civilization would require robust energy systems and possibly life-supporting technology to survive the star's variability. Such large populations of red dwarfs imply that life must have adapted to survive in such an inhospitable place. If such life existed on red dwarf orbiting planets, it would be much other than anything on Earth and would likely function and appear much differently than anything here on Earth. The ability to learn to adapt to red dwarf stars may well redefine our expectations of what habitability is and potentially change our vision for where life might exist within the universe. What this means for space exploration. This is the finding of strange lights on Proxima B, and it signifies the greatest for the future of space exploration. This now marks a new era of prioritizing and designing missions. Space exploration earlier focused on planets and moons within our solar system and looked for microbial life or habitability. However, if Proxima B's lights are a sign of an advanced civilization, then the missions would shift toward direct investigation of nearby exoplanets, ushering in a new era where interstellar exploration becomes a realistic goal and not a pipe dream. Such a detection would require much more sensitive observation tools and much stronger telescopes to confirm and understand better features of Proxima B. Future missions might intend to place next-generation telescopes with enhanced infrared and spectroscopic sensitivity to investigate the atmospheric and surface composition of the planet with much greater precision. Whether these lights are natural or artificial, it will redefine our concept of habitable planets and guide the future telescope missions. If intelligent life does exist on Proxima B, then space agencies and nations would be challenged to speed up the pace of interstellar probe development. Concepts such as breakthrough starshot, with the goal of sending light-propelled nanoprobes to Alpha Centauri, could get new thrust and funding, making this first attempt at interstellar travel a priority for humankind. Though such missions will take decades to reach, advancements in propulsion and miniaturized technology are closer to reality than ever before. The possibility of extraterrestrial life could, in the face of this, take space exploration to a whole new level, with ethics and international cooperation at an unprecedented level. The existence of intelligent life would pose questions of responsible first contact, cultural sensitivity, and preservation of ecosystems outside Earth. NASA, USA, and private organizations could come up with policies to deal with alien civilizations, including guidelines for exploration and interaction in a manner respectful of extraterrestrial cultures. Essentially, the Proxima B lights are a stepping stone into space for humanity, providing food for thought on what such interstellar exploration would entail. Whether they indicate an alien life or some kind of natural phenomenon, these lights remind us of this vast potential for discovery and maybe even connection with other life forms scattered across the galaxy. Space exploration now stands at the threshold of an era of revolution, fostered by curiosity, technology, and a deepened sense of our place in the universe. Redefining the Search for Extraterrestrial Intelligence, SETI. Mysterious lights on Proxima B have revolutionized the way scientists work in the search for extraterrestrial intelligence, or SETI. They are no longer strictly listening for radio signals. Rather, they are open to new, possible indicators of advanced civilizations. For decades, SETI has listened to alien transmissions, hoping that extraterrestrial life would somehow use radio waves similar to ours. This has opened new avenues for SETI research because a city-like lights around Proxima B might enable civilizations to communicate or just announce their presence in ways not dependent on the use of radio signals. With advanced telescopes like the James Webb Space Telescope, JWST, scientists are now searching for artificial light sources, a new type of techno-signature aside from radio waves. Techno-signatures comprise all detectable evidence of technology, like light pollution caused by cities, chemicals that may point to industrial activities in a planet's atmosphere, or even big-scale structures manipulating energy from a star. Perhaps this steady, concentrated glow on the dark side of Proxima B would present an exciting scenario: a city or chain of cities producing light that can be detected from Earth. The light from Proxima B throws a challenge in the minds of scientists doing SETI research. Instead of waiting for signals to be transmitted into space, broaden assumptions of alien communication and technology by analyzing planetary atmospheres for signs of pollution, industrial gases, among other indirect indicators of life. This is the trend to start biosignatures and techno-signatures as efforts to search for signals through the detection of indications and clues that may, consciously or unconsciously, emit intelligent life, such as excessive heat or unnatural light emission and artificial material production. Another redefined focus of SETI is to research the implications of red dwarf stars as potential hosts of intelligent life. Proxima B orbits a red dwarf, once considered hostile to life because of frequent solar flares and radiation. This is a highly possible scenario. If life indeed flourishes around a red dwarf star, then numerous possibilities of habitable planets occur, considering that the stars are the most commonly distributed in our galaxy. Now, if SETI researchers get to emphasize such red dwarf systems, then that will also increase chances in finding more Proxima-like planets having detectable techno-signatures. This new approach to SETI fosters international cooperation and technological progress. Confirming lights on distant exoplanets requires advanced tools, big data sharing, and global cooperation to pool resources. The potential lights on Proxima B remind us that finding intelligent life may not be about looking for what aliens would deliberately broadcast, but for what they may inadvertently reveal. Redefining the SETI mission and bringing humanity closer to answering the question, are we alone in the universe? But if these signals are proof of alien life, how will it reshape everything we know about ourselves and our future? The potential impact on humanity. The discovery of artificial lights on Proxima B can be profound for the human race, changing its assumptions about life, where it stands in the cosmos, and the responsibility an explorer has in reaching this place. This moment of discovery would have to mean that these lights were artificially created by another intelligent form of life from this galaxy, marking one of the most important points in the history of the human race, changing how one might understand what is to be intelligent and conscious in the universe. These changes may redefine human existence and give rise to a worldview on life, technology, and even civilization. Philosophical and spiritual impact, the most immediate would be: for thousands of years, human cultures, religions, philosophies have been speculating about the uniqueness of our species and its purpose, and confirmation of intelligent extraterrestrial life would awake the world to dialogue with itself, questioning established creeds and seeking new representations of our existence. Indeed, this would bring some form of unity among individuals as we redefine ourselves belonging to a larger cosmic system. On a scientific level, the discovery of an advanced civilization on Proxima B could be revolutionary for the technology and knowledge we obtain. The research of an energy source from this civilization, architectural structure, or environmental adaptation can help develop insights that might lead to breakthroughs in energy and sustainability and the engineering side of things. If that alien civilization survived near the red dwarf star, perhaps its technology would help humankind cope with the adverse environmental issues plaguing the Earth, like climate change and energy demands. Ethical issues would also be raised to the forefront, as humanity would be faced with unprecedented questions about how to responsibly approach or communicate with another civilization. Historically, human contact between different societies has led to cultural disruption or exploitation. Governments, scientists, and ethicists would have to develop protocols for potential contact to ensure that any knowledge and technology exchanged is mutual and respectful of each civilization's autonomy. The extraterrestrial intelligent contact may then create a new international cooperation. The size and importance of interstellar space exploration would require the cooperation of the globe, putting together different nations in unified lines to share resources, research, and technological progress. Thus, the discovery of Proxima B may become a factor for peace and shared purpose, reminding us that in the vastness of space, humanity is one species with a common destiny. In every sense, this discovery would extend far beyond science, transforming culture, philosophy, and our collective vision for the future. The responsibility and challenges of first contact. The discovery of artificial lights on Proxima B raises the possibility of humanity facing the edge of an unimaginable possibility. First contact with an extraterrestrial civilization. With this potential comes great responsibility and more complex challenges. Unlike a human civilization-to-human civilization encounter, which often left the two in conflict with each other or caused turmoil in the culture, human civilization's stakes in potentially dealing with an advanced civilization are much higher. A mistake in the races would be very devastating, as it raises ethical, logistic, and existential questions that will have to be taken extremely carefully. One of the key challenges will be communication. It will be really hard to understand in simple terms how beings developed under other conditions and possibly different biology, psychology, and social structures. We must establish a method of communication. Perhaps the use of mathematics or principles of natural sciences might give us a universal bridge for a first point of contact. A set of protocols has to be formulated regarding the meaningful, respectful, and non-abrasive expressions so that there is an exclusion of risks of conflicts or even being offended through misunderstandings. A very real responsibility is the responsibility not to cause injury. The history of relations of humans with other human civilizations contains exploitation and sometimes unintentional injury to less technologically sophisticated societies. Here, we cannot determine which of these might be the more advanced civilization, but we do have a responsibility not to do anything that might agitate or injure the Proxima B inhabitants. We must tread carefully, protocols in place not to import Earth's microbes, technologies, or even cultural biases that could damage or harm an alien's ecosystem or society. On the security front, this is the first time human history has seen such risk. We would have to weigh the benefit of passing on knowledge to the possible dangers of passing on certain Earth technologies or knowledge which could then be used to harm the Earth itself. However, on the other hand, isolationism has dangers. It is possible that the highly developed civilization might find an alien refusal to open channels with Earth as some expression of hostility. Thus, caution has to be in an openness that builds respectability and safety. Ethics plays a central role in the responsibilities of first contact. Who should represent humanity? Should contact protocols be determined by one nation, or is it essential to involve an international coalition to ensure a fair and balanced approach? Such decisions will shape humanity's first impression and may set the tone for long-term relations. Transparency, global cooperation, and inclusive discussions are vital for building trust both with extraterrestrial beings and among Earth's populations. For after all, the first contact requires a very responsible and thoughtful attitude of humanity. It is at this moment that our understanding of the universe will possibly be rewritten. It does demand patience, respect, and wisdom enough to be willing to make peace above ambition. We could enter this unprecedented meeting with the care and integrity of this kind of endeavor to actually create a relationship between both civilizations that enhances the knowledge of life and intelligence in this universe beyond Earth. As we stand on the brink of possibly discovering alien life, the mysteries of Proxima B remind us of the vastness and wonder of our universe. Could this be our first glimpse into a new cosmic neighborhood? Let us know what you think in the comments below. If you enjoyed this deep dive, don't forget to like, subscribe, and hit that notification bell so you never miss an update on our journey through space. And before you go, click the next video on your screen for more fascinating discoveries. Thanks for watching.